right, fifth grade. Today's math deals with page 458. Hope you have your math book open to it and had a chance to look over the page because we're doing triangles. Triangle, of course, is a polygon with three sides on it. You learned that many years ago. But you probably don't remember what we're taught it once before is that angles inside a triangle always add up to 180 degrees. And that a triangle will always have three angles in it. Okay, so here's a triangle. 1, 2, 3 sides. Here is an angle. 1 angle. 2 angles. 3 angles. On this third one, number 1. Number 2, and number 3. So there always are 3 different triangles with 3 different sides. Here's triangle 1, angle 1, angle 2, and angle 3. So we got 3 angles inside the triangle, and we have always 3 sides on the outside of a triangle. Okay, so there's an angle inside, angle inside, angle inside, and then we have the sides on the outside of a triangle, 3 sides. So 3 angles in it, 3 sides on the outside. And that's important because triangles are classified by the length of their sides on the outside and by the measurement of their angles on the inside. So it's very important that you look at page 458 and read through that a couple of times. I'm going to go over it briefly. As you watch the video, you might need to pause and kind of read it and study it a little bit. First, classifying by their sides. Okay, the outside. We could call it 1, an equilateral triangle. It's equilateral if all the sides, the length on the outside, is the same. Okay, so the same length. Now you can use a ruler to measure, but here's a quick hint. If all the measurements are the same on the inside, the lengths are going to be the same on the outside. So today when you do your assignment, you don't really have to measure the sides, just check the measurements. If all 3 measurements are the same, then the length of the sides are the same, and we call that an equilateral triangle. Number 2, an isosceles triangle. Isosceles triangle is a triangle with at least 2 sides the same length. When we say same length, it's another word as congruent. So if you've heard that word before, congruent means the same length. Again, you can look at the measurements today. If 2 measurements in the inside of the angles are the same, 2 sides will be the same length or congruent, and you'll be able to say that's isosceles. The third way we classify is called scalene. No sides the same length. In other words, no sides are congruent. Okay? And again, you can look at the measurements on the inside to see that if all 3 measurements are different, none of the sides are the same length. No measurements the same, then none of the sides. So if you want to hit pause here and kind of look on page 458 to get those 3 different names: equilateral, isosceles, scalene, because this is rather quickly. Okay? Second, we can classify a triangle by the degrees of the angle in the inside of it. Page 458, now we're getting down toward the bottom. There is, first of all, a right triangle. That means inside, just one of the degrees is 90. Obviously, you can have more than that because 90 plus 90 plus a third side would get you over 180. All of them have to add to 180. So if just one is 90 degrees, it's a right triangle. If the degrees on the inside and all 3 angles are less than 90, all 3 less than 90, then we say it is acute. And the third one is obtuse triangle. It will have one measurement of greater than 90 degrees, and the other two will be less than 90. But if it has just one that's greater, we call it obtuse. Again, you might want to pause and look and study at the bottom of 458. Going on, examples then of how we're doing today's assignment. Here is a triangle. Can we classify it? Keep your book open to page 458. You're going to need that book open all through your assignment. I'm looking at this and I see a measurement of 78, 77, 25. All three are different measurements. Okay? That means all three sides are different. If all three sides are different, we're going to classify it as scalene. So I write that on the line. All three sides different. Now, inside are different measurements. Do we have any with a 90 degree? Nope, so it's not a right triangle. Do we have all numbers less than 90? This is, that is, and that is. So we say it's acute triangle. So this one would be classified as a scalene acute triangle. All right, here we go again. We want to give two names for it. First, by the length of its sides. Here are the three measurements for us. If the three measurements are all the same, we know the sides are the same. They're not. If all three are different, then we know all three sides are different, and they are. So we say again, scalene. Three sides different. 20, 135, 25. Now I'm going to look at the angles on the inside. Are all the numbers less than 90? Yes. 20, yes there, but 135 is not. So it's not acute. Are one of my numbers 90 degrees? Nope. So it's not right. If one of my numbers larger than 90? Yes, it is. When we have one angle with a measurement larger than 90, we say it is obtuse. So this triangle would be a scalene, obtuse triangle. Two different names for classifying it. Here's another one. The length of the sides, we could measure how far that is, and then measure there, then measure there to check. But we can look at the measurements. Since two of the measurements are the same, there's a 45 and a 45, then I know two of the sides are the same length. And when two of the sides are the same length or congruent, we say it is an isosceles triangle. Two of the sides are the same length. And now we're going to look at the measurements themselves. Are all three less than 90? Nope, two are, 45 and 45, but 90 is not less, it's equal. Are one of the sides equal to 90? Yes. So we call this a right triangle as well. So this triangle is an isosceles right triangle. All right, now on your sheet, you're going to name three things. It's going to look like this. All your problems will look identical to this. Okay, so first of all, we've got to figure out what D is. That's our variable. Well, we know that all three numbers, when added up, have to equal 180. All triangles equal to 180. So what we want to do is subtract 70 plus 50, whatever that number is. Well, if we add these two together, we get 120. 70 plus 50 is 120. So I'm going to subtract 120, and I get 60. That is what D is equal to, because that third measurement should be a number that adds up to 180. So I can check 70 plus 50 plus 60 will get me 180. Now I can do my naming. This now is 60 degrees, I know that. All three degrees, 60, 50, and 70, are different measurements. It is scalene then. and all three measurements, 70, 50, and 60, are less than 90, so it is acute. Acute scalene triangle. All right, here we go. We need to get it so that all three measurements, that's our variable r, equal 180. 30 plus 30 equals 60. So I'm going to subtract 60 off over here. I get 120. So that's my third measurement. I know now r equals 120 degrees. I can write that in right there. All right. My three sides. If the three measurements are all the three same size, same number, it is going to be an equilateral. They're not. But two of my numbers are the same, 30 and 30. So it is an isosceles. Two sides the same. Are all my measurements less than 90? 30, 30, 120? Nope. Is one of them greater? Yes, 120. So it is an obtuse triangle. Okay, isosceles, because all three measurements are different. Obtuse, one of the numbers is bigger. How did I get r? We added three numbers so that it would get to 180. Last example. Again, we got to find out what e is. So 45 plus 45 plus e is going to get me my 180. Got to get 180 degrees in all of them. If you take your calculator, 45 plus 45 is 90. So I got to subtract 90. And what I got? I got 90 degrees. That's what E is, so I'll write that in the blank. And you can double check that with your calculator. Take 90 plus 45 plus 45, and you will get 180, what all triangles need to add up to. So I've got my first part done here. Now I look at, I'm going to write 90 down here, so I got it. Are all three numbers the same? Nope. So it's not an equilateral. You will have some today where all three numbers are the same. Are two of the numbers the same? Yep, 45, 45. So again, it's isosceles. Are all three numbers less than 90? Nope. One of the numbers 90? Yep. It is a right triangle. So three things today. When you label them, you're going to need to find the degree of the variable and find out what do my first two measurements add up to. Subtract that from 180. That will be what your variable equals. I like to write it in. Then check your three numbers, the measurements. If they're all three the same, it is equilateral. If two of the numbers are same, like this example, then it's isosceles. If all three are different, it's scalene. Then my third thing I need to label is, do I have all three numbers that are less than 90? Then it's going to be acute. If one of my three measurements is 90, it's going to be right. And if one of my numbers is greater than, it is obtuse. All right, that's a quick example. You need to study page 458. When you do your sheet, three different things just like this slide and this one, where you're going to find the R and then label according to the different types of measurements and the length of the sides, using the measurements to guide you.